Welcome students, let's continue chapter 4 Physics ICSE 10th standard Real and Apparent Depth. An object placed in a denser medium when viewed from a rarer medium appears to be at a less depth than its real depth. This is because of refraction of light. So we have an image from internet here. See, you can see here. Now the apparent depth of a glass block is less than the real depth. The fish appears to be nearer than it is actual. See, for example, in this image, the actual fish is here, but when you are viewing at this angle, it appears that the fish is here. The full glass mug appears to hold more root beer than it actually does. So compared to this, these effects are due to refraction of light whenever it crosses a boundary between air and another transparent medium. We will see the bending of stick. So this is apparent bending of a stick under water. See here we have a stick which is AO, and the rarer medium is air and the denser medium is water, and a person is viewing from here, and the stick appears to be bent here like this, and the actual distance is here, but you feel that it is bent and the end is here. This is called the apparent bending of a stick under water. See, what happens here is the portion of this is appears here. So we have some consequences. So the consequences due to the refraction of light, which we come across in our daily lives, like a star appears twinkling in the sky. The sun is seen a few minutes before it rises above the horizon in the morning, and in the evening few minutes longer after it sets. A coin kept in a vessel and not visible when seen from just below the edge of the vessel can be viewed from the same position when water is poured into the vessel. Next is a print appears to be raised when a glass block is placed over it. A piece of paper stuck at the bottom of a glass block appears to be raised when seen from above. A tanker appears shallow than its actual depth. A person's legs appear to be short when standing in a tank. An object placed in a denser medium, when viewed from a rarer medium, appears to be at a lesser depth. An object placed in a rarer medium, when viewed from a denser medium, appears to be at a greater distance than its real distance. These are all few examples which we can write for the consequences of the refraction of light. We'll try to understand what is critical angle and total internal reflection. Critical angle is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rarer medium is 90 degree. And the factors which affect the critical angle is the color or the wavelength of the light and the temperature. And now when it comes to the total internal reflection, so we have to go to this image. See here, the total internal reflection, where there's a change in the incident angle of the light on the block. The reflected light varies at a certain angle called the critical angle. All the light is reflected and none is refracted. When this happens, we have total internal reflection. So critical angle and the total internal reflection are related. See, when there is no refraction, and that angle is called the critical angle. And when there is a critical angle, then you don't have refraction, but you have total internal reflection. We will take one more example from the internet. See, total internal reflection occurs when light is passing through a medium, call it 1, like glass or plastic, with an index of refraction n1. Outside the material is a medium like air, call it 2, with an internal index of refraction n2. For certain angle of incidence for light striking the interface and going from medium 1 to medium 2, light will not pass through the interface but will be totally reflected inside the medium. This occurs primarily when the light strikes a glancing blow on the interface. For a thin material of medium 2, like a fiber, these angles will always be small and the light will stay inside the fiber. This process called total internal reflection. Consider the refraction of light from a denser medium to a rarer medium. When a light ray traveling from in a denser medium falls into the surface separating it from the rarer medium, it is partially reflected back into the denser medium and partially refracted in the rarer medium. This refracted ray bends away from the normal on the surface at the point of incidence, obeying the law of refraction. So now as the angle reduces, so what happens? See, when the angle of incidence is small, so what happens? The intensity of refracted ray keeps on decreasing. When the angle of incidence is equal to critical angle, then no refracted ray is obtained. Only total internal reflection will take place. When the angle of incidence is greater than the critical angle, then no refracted ray is obtained and the incident ray is totally reflected. Now, critical angle. We have read, okay, that when a ray of light passing from a denser medium to a rarer medium at a critical angle incidence IC, the angle of refraction becomes 90 degree. That is at I is equal to IC, that is critical angle, and R is equal to 90 degree. The angle IC is called the critical angle. The critical angle is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rarer medium is 90 degree. Now we have the effects of color of light with respect to this. Now, the refractive index of a transparent medium is most for violet light and least for red light. Therefore, the critical angle for a pair of media is least for the violet light and most for the red light. Thus, the critical angle increases with the increase in the wavelength of the light. So, this is with respect to temperature, effect of temperature. On increasing the temperature of the medium, its refractive index decreases. So the critical angle for that pair of medium increases. Thus critical angle increases with an increase in temperature. Now we will understand what is total internal reflection. When a ray of light traveling in a denser medium is incidented at the surface of a rarer medium such that the angle of incidence is greater than the critical angle for the pair of media, the ray is totally reflected back into the denser medium. This phenomenon is called the total internal reflection. So for this, what is the essential condition? So we'll try to understand the essential condition for the total internal reflection. The light must travel from a denser medium to a rarer medium. Next, the angle of incidence must be greater than the critical angle for the pair of media. Now, where is the application of this now? See, due to this total reflecting behavior, the total reflecting prism is used for three purposes. So what are the purposes? To deviate a ray of light through 90 degree, to deviate a ray of light through 180 degree, and to erect the inverted image without producing deviation in its path. The first point is to deviate a ray of light through 90 degree. So this is used in the application of, that is, prism. Here this action of prism is used in periscope, where a total reflecting prism is preferred over a plane mirror. The second one is to deviate a ray of light through 180 degree. So where is this used? This action of prism is used in prism binoculars and certain type of camera to invert the image without the loss of intensity. Next is to erect the inverted image without deviation. This action of prism is used in a slide projector. Some consequences of total internal reflection. A crack in a glass vessel often shines like a mirror. Next, a piece of diamond sparkles when viewed from certain directions. So these are few examples. Now we will see the distinction between total internal reflection and reflected from the plane mirror. Total internal reflection. It takes place only when the light passes from a denser medium to a rarer medium at an angle of incidence greater than the critical angle for that pair of media. Next, reflection from a plane mirror? It takes place when light is incidented on plane mirror from any medium at any angle of incidence. Second point for total internal reflection, the entire light is reflected. In plane mirror, only a part of light is reflected while the rest is refracted or absorbed. Third point, there is no loss of energy. The energy of reflected ray is same as of that incident ray. Whereas in a plane mirror, there is a loss of energy. That is, the energy of reflected ray is less than that of incident ray. Total internal reflection, the image is much brighter and the brightness remains unchanged even after long use of total reflecting devices. Whereas in a plane mirror, the image is less bright and the brightness gradually decreases as the silvering on mirror becomes old and rough.